With the modern introduction of electric vehicles, concerns have been raised that electric cars are less efficient in energy consumption than their combustion-based counterparts. Many argue this is because production emissions of electric vehicles and their usage emissions outweigh the emissions of combustion vehicles. The guiding question in our inquiry will be whether electric cars are as efficient as portrayed and whether they are a possible way to bring down daily emissions effectively. Carbon emissions have been on the rise since the beginning of the Industrial Revolution. Since Henry Ford popularized the automobile in the early 20th century, more and more Americans have been buying cars. Only recently, the environmental impact of cars has been assessed. While regulations on carbon monoxide have been in effect on cars in the United States since 1973, these regulations have historically been loose and environmentally poor. With the recent push on climate change, the Obama administration significantly tightened federal regulations on carbon emissions from cars. The state of California subsequently placed even stricter regulations on chemical emissions from vehicles. We predict that electric cars will be more efficient in energy consumption than combustion vehicles because despite their larger production emissions and their connection to fossil fuel resources, replacing combustion vehicles with electric cars globally would be a practical method in decreasing emissions efficiently.
Methods and materials. We'll basically be using this website called Climb Mobile, and we'll be inputting 4 sets of 2 cars and getting data out of it. One will be a combustion vehicle and one will be an electric vehicle. The first set is the Toyota RAV4 2017 against the Tesla Model X Performance 2019. The second is the Toyota Land Cruiser 2017 against the Tesla Model S Performance 2019. The third is the Nissan Note 2017 against the Nissan Leaf 2017. And the fourth is the Hyundai Grand Sonata Fe 2014 against the Hyundai Kona Electric 2019. With these comparisons, we'll be given the mass of equivalent carbon dioxide released per kilometer of each car within a bar graph and a picture number line graph. And then we'll also see a direct comparison with the comparative line graphs displaying the total emissions as well as the average emissions of each of the vehicles side by side. Okay, data. So for each of the cars, we found the average emissions after 100,000 kilometers as well as 500,000 kilometers. We also found the emissions from electricity generation and charging for each of the electric vehicles. And we also recorded the distance that the electric vehicle is cleaner after in comparison to the combustion vehicle. For example, in comparing the Toyota RAV4 to the Tesla Model X, if you want to find the electric emissions, which is the Tesla, after 500,000 kilometers, it would be 85.1 grams of equivalent carbon dioxide per kilometer. If you want to find the distance that the electric vehicle is cleaner after compared to the Toyota RAV4, it would be 64,195 kilometers. There are also some of the graphs that we found on the side of the table, but the rest of them are very similar.
Based on our data, in all examples, the initial emissions of the electric vehicles are greater than that of the combustion vehicles, as seen by the line graphs which display higher initial total emissions and average emissions for the electric vehicles. However, as electric cars are used more, they become more energy efficient, as their average emissions drop exponentially. After a certain amount of kilometers, each electric vehicle drops lower than the combustion vehicle in both total and average emissions. For example, in the comparison between the Toyota RAV4 and the Tesla Model X Performance, both the initial average emissions and initial total emissions of the electric Tesla are double the amount of the Toyota's. But after 64,195 kilometers, the Tesla becomes more efficient than the Toyota, with the Toyota's average and total emissions exceeding that of the Tesla. The effects of the increased efficiency of the Tesla can be seen in the comparison of each vehicle's emissions at 100,000 kilometers. The Tesla's emission rate is 240 grams of carbon dioxide equivalent per kilometer, whereas the Toyota's emission rate is significantly higher at 310 grams of carbon dioxide equivalent per kilometer. This same pattern occurs very similarly with the rest of the comparisons. However, the other comparisons show that the electric vehicles become cleaner than the combustion vehicles in shorter distances than the first comparison, with the lowest being 15,795 kilometers and comparing the Hyundai Grand Santa Fe and Hyundai Kona Electric.
Our conclusion. As our hypothesis predicted, while having a higher initial emissions footprint due to production, electric vehicles make up the deficit due to their significantly lower charging emissions and emissions over their total lifetime. From the data we gathered, the average distance that an electric car must travel to be more efficient than an internal combustion vehicle is 36,050 kilometers. While the distance for each electric car is different depending on many factors, at some point in the electric car's lifetime, it will become more efficient than an internal combustion vehicle. Right now, the major setback of electric vehicles is their lack of production infrastructure, which causes production emissions to be higher because of non-streamlined production methods. Once this major setback of electric vehicles is addressed through car manufacturers dedicating more factory floor space to production and better methods of production are created, the benefits and price of electric vehicles will undoubtedly change the car market forever. For further research on this topic to gain a better understanding, an analysis of production techniques that decrease emissions for electric vehicles is needed to further cement our claim. Electric vehicles are still a small part of the car market, meaning not many companies make more than one electric model. Because of this, once more companies have a broader array of models with comparable classes, the comparisons will be much more accurate because you can compare one class of electric vehicle to a corresponding class of combustion vehicles.